In this video, we're going to learn about when functions are increasing, decreasing, and also about what we call extreme values of functions. Let's start by talking about increasing and decreasing. Let's imagine that we had a function that represented the amount of money that we have in a bank account. Maybe our function looks a little something like this. So in this case, the x-axis is representing time, and our y-axis is representing the amount of money in our bank account. So what we notice is that there are some different behaviors that we see for this function. If we look at this part of our function, we can see that the amount of money in our bank account is going down, and it keeps going down until it gets to this point. And at that point right there, the amount of money in our bank account stops going down and starts going back up until it reaches this point here. And then after that point, the amount of money in our bank account starts going back down again. So that's all we mean when we talk about a function being increasing versus decreasing. So in this interval right here, that's a place where my function is decreasing. In this interval here in the middle, that's a place where my function is increasing. It's going up as I go from left to right. And over here, that's a place where my function is once again decreasing. So a typical function can increase a bunch of times, it can decrease a bunch of times. Sometimes the function will always be increasing, sometimes the function will always be decreasing. It really varies from function to function. Now let's look at a function where we have a little more specific information. Once again, if we wanted to talk about increasing and decreasing, a problem might ask you, on which interval is the function increasing? Well, you might realize that the function is increasing, and visually all you're looking for is the function going up as you go from left to right. So the function is going up as you go from the point 0, 1 to the point 3, 6. Now when we talk about the interval on which the function is increasing, we're always talking about an interval of x values. So we would say from x equals 0 to x equals 3. So it starts increasing at 0 and it stops increasing at 3. Now notice that we're a little bit specific about the endpoints here. At the point x equals 3, technically the function isn't increasing there anymore because the function has leveled out, it has stopped increasing, and it's about to start decreasing. So we include 0 because the function is clearly increasing there, but we don't include 3 because that's right at the point where my function has stopped increasing. Now after I pass x equals 3, my function starts decreasing. So if I were asked, on which interval is my function decreasing? Again, I don't include 3, that's a point where my function is actually neither increasing nor decreasing. And it goes up to 4, and again I don't include 4 either because that's another point where my function has leveled out. Now what happens after 4? Well, you might notice that after x equals 4, my function starts increasing again. And so I'm going to add that interval on to my increasing answer. So not only was my function increasing from 0 to 3, it's also increasing from 4 to 5. Alright, so we've covered all of the numbers between x equals 0 and x equals 5. That's the domain of our function that we've seen here. But what about those numbers 3 and 4? My function isn't increasing at 3, it's not decreasing at 3. It's not increasing at 4, it's not decreasing at 4. And those numbers where it has stopped doing one thing and started doing the other thing, that's what we call an extreme value. So at x equals 3, we have what we call a local maximum. So it's a maximum because this y value, y equals 6 here, is the biggest y value in the neighborhood. That's the biggest y value we see near x equals 3. Similarly, at x equals 4, that's a local minimum. And again, because that y value, y equals 4, is the lowest y value we see in the neighborhood. There's another kind of maximum and minimum, and that's the absolute maximum and the absolute minimum. The absolute maximum is the highest y value we see for the entire function, and that happens also at x equals 3. So at x equals 3, not only do we have a local maximum, we also have an absolute maximum. Do we have an absolute maximum at x equals 4? Well, no. This minimum value is just a local minimum. This is the lowest y value that we see in the neighborhood. there are lower y values in this part of my function. So this point 0, 1, that's where my absolute minimum is. So the difference between local and absolute is that local maxima and minima are places where my function stops increasing and starts decreasing, or stops decreasing and starts increasing. The absolute maximum is just the biggest y value, and the absolute minimum is just the lowest y value.